Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 17 of a unit Electrostatic Potential and Capacitance. Today we are going to discuss about the previous year asked questions. In this session I have covered all the questions that have been asked in the engineering competitive examinations. So let's begin then. But before we start, I request you guys that whether you are a medical aspirant or whether you are an engineering aspirant, you need to attend both the sessions. That this is the PCQ one. It's in previous year asked questions first session, and the next would be the PCQ2. It's in previous year asked question. In that session, I am going to cover the questions that have been asked in the medical examinations. So if we see in a real manner that we cannot identify that which questions can be asked only in engineering examinations or which question can only be asked in medical, so you need to attend both. Yes, one more thing, please have your pen and paper, and what you are supposed to do is once you have a question, you are going to pause the video and just try to attempt it. If you can attempt it, well done. If you cannot attempt it, don't worry, don't bother about it, just play the video. I would be there to solve this for you guys. So I hope you understand the thing. Yes, let's begin then, and all the best. This is your exam, so let's begin. Yes, what the data has been given, the data said that assume that an electric field E is equals to 30x square I cap exists in space. Then the potential difference VA minus V naught, where V naught is the potential at the origin and VA be the potential at x equals to 2 meter is. So what you are going to do is, first tell me, do you have any relations which can relate for you electric field and potential, or I can say potential difference? Yes, we have a form. It's an E is equals to minus of dV by dx. I hope you remember this. So what I can write dV is equals to minus of E ds. If I integrate this both the sides, what would be the happen? So if I integrate this from dV, it's an begin with the V naught, ends with the VA. Here V naught, it is at origin, they said it's an origin, and potential at the A, that is at x equals to 2 meter. So if I put a limit, it is a VA minus of V naught, then equals to minus of integration of E, it is a 30x square dx. I need to integrate this from 0 to 2. So let's begin then. Minus 30x square, it's an 30 multiplied by x cube divided by 3, and this limit should be from 0 to 2. If I do this and try to solve this, then what I can have is it's a VA minus of V naught, that should be is equals to minus of 30 by 3 into bracket x cube, and the limits was from 0 to 2. It is minus of 10 into bracket x cube, it's a 2 cube, minus 0 to cube, that which means nothing, minus of 10 into 8, this would be a minus of 80 volt. I hope this is done by you guys as well. Yes, do you landed on the same answer? Have you? Do you get the same answer? Yes, great. So let's move to the next question. Next question, look at this very carefully and do it quickly. Look at this. What the question says, an alpha nucleus is there, and an alpha nucleus of energy half mv square bombards a heavy nuclear target of charge Ze. Okay, then the distance of closest approach for the alpha nucleus will be proportional to, okay, what they want. Do you get any idea of this? Do you have any idea of this? What is closest approach and what they mean? What they mean is that let's suppose this is the target nuclei and this target nuclei having a charge of Z into E. Alpha nucleus is there. Let's say this is alpha nucleus. It's, if it is an alpha, it's in 2He4, that you know, and it is having an energy of half mv square. Yes, let's say initially it is very far, and when I say very far, then I mean I may be at infinite distance. Now let's suppose it is moving in this direction, it is moving in this direction, and if it is moving in this direction, then by moving in this direction, let's say a certain time will arrive, let's suppose this, or a certain distance arrive. At this point, this alpha particle is comes to a rest. Okay, so the thing would be, this would be the distance, this is the distance d, which is of closest approach. One more thing is that why did it come to rest? Why did it come to rest? Any reason for it? Please think. Any reason to come to rest? If you analyze the situation, this is the plus charge, even this is the positive charge. This two will repel each other. So what the thing happened, that it is the energy, it's an kinetic energy which will make my alpha particle moving in the positive x direction, and it is the force of repulsion, because force of repulsion would be there, and that force is acting in this direction. So it is the force of repulsion that will make that energy, that means the kinetic energy of a charged particle will be decreasing by 1 and over. Yes, so at a time will come that complete energy will be over, that means my particle came to a rest, and now onwards, if you see the situation after it is coming to a rest, it is moving in this direction because force is repelling it. I hope these things are clear, is it? So let's then start the numerical. Let's have a rough sketch one more time, that this was the plus Ze charge, and this would be the half mv square, it's an alpha particle. Let's start from a infinite, it has came to reach, and that came to a rest. Let's say this is the distance d, and it is my closest distance of approach. So what the thing will be, that suppose this is the location A, this is the location B, and if I write total energy at A, that must be is equals to total energy at B. Yes, so when I say a total energy, my mean is potential energy plus kinetic energy at A, that should be is equals to potential energy plus kinetic energy at B. So what is potential energy? When we say that potential energy at infinite is considered as in 0, so it is 0 plus kinetic energy that has given, it's an half mv square, that should be is equals to potential energy at B. Potential energy at B, that is K multiplied by Q1 multiplied by Q2. Q1 would be a ZE, Q2 it's a 2He4 multiplied by 2 divided by the distance, it's a D, plus kinetic energy. Look at this, it came to a rest. When it came to a rest, it would be a 0. I hope these things are clear, is it? So what I can have is that half mv square should be is equals to K multiplied by 2 multiplied by ZE divided by D. So this D should be is equals to 2 multiplied by charge Q1 multiplied by charge Q2 divided by half of the mv square. So it can depend on this many factor. Now you need to check your options and execute the answer. I hope this is clear to you, is it? So can you do this kind of questions? Can you do this kind of questions? Are you sure? Can it be done? Can it be? Yes. So shall we move to the next question? Shall we? Let's move then. Look at the question, go through this. What the question says, that two thin wire rings are there. Each one is having a radius of r, are placed at a distance d apart with their axis coinciding. The charges on the two rings are plus of q and minus of q. The potential difference between the centers of the two rings is, yes, this is the question. How can you do this? How can you do this? First, let's have a rough sketch of this. What the data says that, let's suppose this is one of the ring, this is another ring. The both have been given a charge. One is plus q and another is minus of q. So one is plus q, another is minus q. Their radius is r and their separation was d. Okay, distance d apart. So distance from center of the one of the ring to center of the another ring, it's in d. What do you need? You need the potential difference. So how can you do this? Let's say this is point A, this is point B, and let's write the potential. So what potential at A is all about? First you need to write a potential due to this charge. What is it? It's a kq divided by r at point A. Now I need to write a potential at A due to minus of q charge. What it would be? Yes, look at this. This is the r and this would be their distance, under root of r square plus d square. I hope you understand this. So this is minus of kq divided by root of r square plus d square. Is it clear? Is it? Great. Next, it's a VB. What is it? It's a first, let me write the potential due to minus of q charge. It's a minus of k multiplied by q divided by r. And then for the plus q charge, it is a plus q divided by under root of r square plus d square. What I need to write? I need to write the potential difference between the centers of the two rings. So what I want the delta V. It's let's say delta V. It is, suppose it's a VB minus of VA. So if I write VB minus of VA, it's a minus of KQ by R plus KQ divided by root of R square plus D square minus of it's in KQ by R minus plus KQ by root of under root of R square plus D square. So if I solve this, I will have this answer. It's a minus KQ by R minus KQ by R. This is minus of 2KQ by R plus KQ plus KQ. It's a 2KQ divided by root of R square plus D square. And now rest of the things can be done by you guys. Yes, you need to just simply solve this. It's in KQ could be a common, and if required then replace the value of K. It's in 1 upon 4 pi epsilon naught, and that all. Yes, but did you understand this? Are you sure? So shall I move to the next question? Yes, shall I? Let's look at this. What the data is saying. They says that a thin spherical conducting shell of radius r has a charge q. Another charge q is placed at the center of the shell. Okay. The electrostatic potential at point P, which is at a distance of r by 2 from the center of the shell. Okay. So how can you do this? What can be done? Yes. So can we have a rough sketch? Yes, a thin spherical shell is there. It is having a charge q, and another charge q is placed at the center of the shell, and you need to find out the electrostatic potential at point P, which is at a distance of r by 2 from the center of the shell. So let's have it. So according to the data, this is a shell and it is having charge q. This is having radius r. It is having a charge plus q at the center of the shell, and you required a potential at this place. This is point P, which is at a distance of r by 2 from the center. So what I need to do is I need to write a potential due to both the charges. Charge small q, it's a charge of a shell, and charge at the center, it is the point charge. So if I write potential at P, I need to write potential due to Q plus potential due to capital Q. Now potential due to Q, it's as it is a charge of a shell, it's a KQ divided by R because it's an inside point, plus as it is a point charge, what I need to write is it's in K into Q divide by distance, and distances are by 2. So this will be K Q by R plus 2KQ by R. So if I try to solve this, it's a potential at P that would be is equals to K by R multiplied by Q plus 2, it's multiplied by 2Q. Yes, this would be the answer. And if they want, it's in this K can be replaced by 1 upon 4 pi epsilon naught. Yes, it's 1 upon 4 pi epsilon naught into R multiplied by Q plus 2Q. Yes, then look at the option and try to arrange it in the same manner as they want. But that can be done, that is not an issue. Yes, I hope this is clear to you. Is it clear to you? Yes, so can you do this? Can you? Shall we move to the next question? Shall we? Let's look at this. What they say is, yes, this is very famous question. It's a two concentric hollow spherical shells are there having radius r and r. This capital R is bigger than the small r. A charge q is distributed on them such that the surface charge densities are equal. The electric potential at the center. First, tell me, what is surface charge density? What is it? Yes, it's a sigma, it's a q by a. This is surface charge density. What is volume charge density? Volume charge density, it's a rho, that is q by v. This is volume charge density. And one more, it's a linear charge density, lambda. It's a q by a, q by l, it's a length. Yes, this is linear charge density. So these three densities are there. Here they says the surface charge density is equal, so their sigma would be unequal. And what you need to write? You need to write the electric potential at their center. So how could you do this? First, let's have a rough sketch of it. What they say that this is the center, and this inner section may be smaller. This is having a radius of r. The sigma, let's say this as a sigma 1 and this as a sigma 2, and sigma 1 equals to sigma 2. So what you are going to write is, if you remember this question, that even this question has been covered in the lectures as well, that sigma is there, which would be a q1 by 4 pi r square is equals to q2 by 4 pi r square. So what I can write is, it's a 4 pi and 4 pi that has been gone. So it's a q1 by q2 is equals to small r square divided by capital R square. Yes, what I else know is that these two spheres have given a total charge of q. So q1 plus q2 would be equals to q. Now if I replace the any one of the value, if I replace how? Something like this, q1 equals to q2 multiplied by r square divided by capital R square. So this q1 is equals to q2 into r square divided by r square. Yes, so if I replace the value of q1 here, yes, it's a q1 plus q2 equals to q. I can get a q2 equals to this, and same way if I replace the value of q2, I can have this value. Yes, so now I am having a charges of this two sections. I am having a Q2, now I am having a Q1. I am having a charges of both the cells. If I am having a charges of both the cell, I want the potential at the center, at this position. So what I can write is that V is equals to K into Q2 divided by R plus K into Q1 by R. I hope this is clear. Yes. So according to the data, what I have written is this is the Q1, this is the Q2, and this is the shell. I hope this is clear. Yes, so it's a 1 upon 4 pi epsilon naught multiplied by Q1 by R plus Q2 by R. Now just replace the value of Q1, Q2 and you will reach to the answer. Yes. Yes. Do you understand this? Do you understand this thoroughly? Are you sure? So can it be done? Can it be done? For sure. Okay, let's move to the next question. Do it quickly. Look at the question. A fully charged capacitor has a capacitance of C. Then it is discharged through a small coil of resistance wire embedded in a block of specific heat S and mass M under thermally isolated condition. Okay. If the temperature of the block is raised by the delta T, then the potential difference V across the capacitor initially is. Okay, how could I do this? So this is the case where you are combining a concept of class 11 and class 12, because the situation that a block is there having specific heat capacity of S and mass M and under thermally isolated conditions, and the temperature of the block is raised by the temperature of delta T. That all you have learned in the class 11. It's a thermal properties of matter. Yes, in that you have a content of calorimetry. Yes, at that point of time you might have studied this. If not, let me give you very quickly that there are two conditions. In a one condition, that temperature of an object increases while phase remains the same. This is the situation where temperature of an object is increases while phase remains the same. So if this is the situation, what I can write is Q is equals to mc delta T. Q is the amount of energy given, M is the mass of an object, C, it's a specific heat capacity of an object, and delta T, it's a temperature difference. This is the case where temperature of the object is changing but its phase remains the same. That means if it is in liquid, it would remain in the liquid, that if it is in the solid phase, it is remain at the same phase. Yes. And one more condition, one more situation where that phase of an object changes, or state of an object, you can say so, phase of an object changes while temperature remains the same. This would be the situation. If it is the situation, then what I can have is Q is equals to M into L. This Q is the again energy supplied to an object, M is the mass of an object, it is a mass of an object, and L, it's a latent heat. required to change the phase. Yes. So here what happens, only the temperature of the block is raised by the delta T. Yes, so what I can write is that energy supplied by capacitor is equals to half CV square. Energy received by a block it's an ms delta T. So what I can write is it's an half CV square should be is equals to m into s into delta T. So this v square should be is equals to 2 multiplied by m multiplied by s multiplied by delta T by c. So what I can write is that it's a v that should be is equals to 2 multiplied by m into s into delta T divided by c in a square root, and this would be the answer. I hope this is clear to you. Is it clear? Yes. So from now onwards, can you do this kind of question? Will it be done? Yes. Are you sure? Yes. Are you sure? Can it be done by you guys? Okay, then let's have a look to the next question, but do it quickly. Yes, what the data is telling me. According to the data, a 20 farad capacitor is there which is charged to 5 volt, and then it is isolated. Okay, it is then connected in parallel with an uncharged, look at this word, it's an uncharged 30 farad capacitor. The decrease in the energy of the system will be, so what can you do? What supposed to be done? The situation is something like this. It is a 20 farad capacitor which has been charged. It's a 20 farad capacitor which has been charged by the 5 volt of battery, and another capacitor is there which is of 30 farad, and it is uncharged. As it is uncharged, this voltage would be a 0. Yes. What I want the decrease in the energy of the system. What can I do is, it's a delta U is equals to 1 by 2 into C1 into C2 divided by C1 plus C2 into V1 minus of V2 whole square. This is one of the situation. It's a 1 by 2 multiplied by C1 into C2. It's a 20 into 30, that is 600 divided by C1 plus C2. It's a 20 plus 30, it's a 50 multiplied by V1 minus V2. It's a 5 minus of 0 whole square, and rest of the things can be done by you. Yes, it's a 50 12s are 600 and 2 6 are 12. It's a 6 multiplied by 25. It's a 150 joule. This is the situation if you remember this formula. This is the situation if you remember this formula. If you don't know this formula, or you might forget this formula, then what can be done? Let's look at the logical approach of the same question. What I can do is that I have charged this, and my another capacitor is uncharged. This is of 20 farad that has been charged with the 5 volt. This is of 30 farad and which has been uncharged. So what I supposed to find it out is, first I need to find out the VCM. It's a common potential. The common potential can be calculated as a C1 V1 plus C2 V2 divided by C1 plus C2. So the C1, it's a 20 multiplied by 5 plus C2, it's a 30 multiplied by 0 divided by C1 plus C2. It's a 20 plus 30, that is 50. It's a 20 into 5, which is 100 plus 0 divided by 50. It's a 2 volt. I hope this is clear. Now Now what you need to write down is it's an energy initial. The initial energy would be equals to half into 20 into V square. It's a half CV square. It's a 25. For the final energy, what you need to do is it's an half into bracket C1 plus C2 multiplied by VCM square. Yes, because these two are connected parallelly, and if these two are connected parallelly, their equivalent capacitance would be equals to C1 plus C2. Yes, yes. So it's 1 by 2 multiplied by C1 plus C2. It's a 20 plus 30. It's a 50 multiplied by 4. Yes, so this is 100 joule. This is 250 joule. Now initial energy were the 250 joule, final energy would be the 200 joule. So whatever the change, it's an initial minus of final. It is the loss of an energy, and that would be a 150 joule. I hope this is clear. Is it clear? Yes. So can it be done? Can it be? Will you be able to solve this? Yes. Are you sure? Are you sure? Can it be done? Great work. So please remember both the approach, because if you remember the first approach, it would be a very fast. It can be done very quickly. It will save a time for us, and if time will remain, I can go for the certain questions which are very calculative. So, and if you forget the formula, you must know what the logical approach is. Yes. So this too, you should go through this too. Next question. What this is? It's according to the data, work done in carrying an electric charge Q1 once round a circle of radius r with a charge Q2 at the center of the circle. This is what they require. What they say is it's a one of the circle is there, and at the center of the circle charge is there. This charge is of Q2, and one electric charge is there Q1. You need to take this charge Q1 round the circle, and this radius is given as an r. This is the situation. So what you need to do is, let us consider arbitrarily any 2 points. Let's say this is VA and suppose this is VB. Write down the potential at A and B due to this charge Q2. So what I can write is it's in VA is equals to K multiplied by charge, which is at Q2 divided by radius. Now let us write down the potential at B. It is a K multiplied by charge Q2 divided by radius of R. This is VB. This is potential at B. It's an K multiplied by Q2 divided by R. I hope this is clear. Is it? Yes. Now what you need to do is it's in work done. So delta V is equals to work done divided by charge. Here you are going to write down that charge which is to be moved. It's a Q1. But as I know that delta V would be equals to VB minus of VA, which is 0. So this work done will be a 0. Yes. This work done will be a 0, and this kind of surfaces are considered as the equipotential surfaces. Do you remember this? Do you remember? Yes, this is the equipotential surface, and work done to bring a charge from one location to another location on an equipotential surfaces would be always 0. I hope this is clear. Is it? Are you sure? Great work. Shall we move to the next question? Shall we move to the next question? Are you sure? So let's have a look then. Look at the question. Go with the data. What this is, considered a parallel plate capacitor of capacity 10 microfarad filled with an air. Okay, so when it has been filled with the air, that means nothing has been placed and air has been used as a dielectric slab. Then the capacity of this PPC, it's a parallel plate capacitor, is 10 microfarad. Now when the gap between the plate is filled partially with a dielectric of dielectric constant 4 as shown in the figure, the new capacity of the capacitor is, okay, so what can you do, what can be done? Let's have a look. That first look at this. This is the situation. This has been filled with the dielectric slab, and the remaining capacitor are remaining area is the a by 4, and this filled is a by 2. So if I consider this as a first capacitor, this as a second, this as a third, let's just write it down, the value of C1, C2, C3. I know that C1 and C3 having same cross sectional area. The separation between two plate is 4D as well, D only. Yes, so let's write down C1 by C2. It's epsilon naught A by D, but my A is the A by 4, so it's epsilon naught A by 4D. Yes, and I know that my C, it's a previous C, it's an epsilon naught A by D, which is a 10 microfarad. Yes, so this is epsilon naught A by 4D, it's a just C by 4, so I have written it as a 2.5 microfarad. Next it's a next is the C2, it's a epsilon naught A by 2. Here it would be a epsilon naught A by 2D. Yes, and if it is an epsilon naught A by 2D, it's a 5 microfarad. I hope this is clear. Yes, now let's write it down. This C is equals to C1 plus C2 plus C3. Yes, this is 2.5 plus 2.5 plus 5. It's a 2.5 plus 2.5 plus 5, something like this. And you know the answer. I hope this is clear. Is it clear? Yes, epsilon naught A by D. Is it clear? Yes. So can it be done? Okay, then let's move to the next question very quickly. What this is a thin plates, each of area A, of 4 identical capacitors are arranged such that the adjacent plates are at a distance d apart with air as the medium. The plates are connected to a source of V volt. This is a battery of V volt as shown in the figure. The charge on the plate number 2 is, yes, they want charge on the plate number 2. How can you do this? Can it be done? Can it be? So there are 5 plates, 1, 2, 3, 4, 5, and if I arrange this, then what I know is that's a plate number 2 and 4 has been connected with the positive polarity. This is positive, this is negative, that you know. Yes, so first let's arrange it. Let's arrange this as the situation's on. The situation is that 2, 3, 4, 5. Let me redraw this. Okay, 1, 2, 3, 4, 5. Okay, so the situation is 1, 2, 3, 4, 5, And which are the plates they are connected? A 2 and 4 is connected. Let me give them a number: 1 2 3 4 5. That's 2 and 4 has been connected, and this 1 3 and 5 has been connected. Yes, this are connected. Yes, 1 3 and 5, and 2 and 4 has been connected to the positive terminal of the battery, and this has been connected to the negative terminal of the battery. This would be the situation. Yes, so I know this, that this 2 will make one of the capacitor, this 2 will make one more capacitor, this 2 will make one more capacitor, and this 2 will make one more capacitor. Yes, so let's first rearrange this. Let's first rearrange this diagram so that we can have a C equivalent, and then we can move further. So how can I do this? How can I do this? Every alternate plate has been connected. So what I know is, and what I can do is that let's first make a capacitor 2 and 1. That means the plate number 2 and plate number 1. Let's first arrange it. This is the capacitor. Yes, it's a 2 and 1. So let me give them a number. It's a 2, and this is the plate number 1. Yes, now I need to make one more capacitor between plate number 2 and plate number 3. Yes, so what I need to do is that suppose this is plate number 2, plate number 3. Yes, so this is plate number 2 and plate number 3. Yes, now plate number 3 and plate number 4, plate number 3 and plate number 4. This is 2, this is 3. Next, plate number 3 and 4. So this is plate number 4, plate number 3. As 2 and 4 are connected, they are the same plates. Yes, and one more thing, one more capacitor would be from plate number 4 and plate number 5. So what I can do is that this is the plate number 4, this is the plate number 5. That this would be the plate number 4, this would be the plate number 5. So if I find it out, if I try to find it out, the C equivalent, I consider that first, second, third, fourth, there are 4 capacitors are connected in parallel, and when they are connected in parallel, it's a C plus C plus C plus C, it's a 4C. So that should be is equals to 4 into epsilon naught A by T. This is the C equivalent. Now what you need to do is that let's find it out the charge through each branch. Let's find it out the charge through each branch. If I assume that let us suppose charge through this, it's a Q1, it's a Q2, it's a Q3, it's a Q4. Yes, so what I can have is that Q is equals to C into V. My C is 4 times of epsilon naught A by D multiplied by V. This is Q total. As I know that every branch have a same capacitance, so charge would be divided equally. So what I can write is Q1 equals to Q2 is equals to Q3 is equals to Q4. That would be equals to, each one will carry a charge of epsilon naught A by D multiplied by V. This is the charge of each branch. Now what do you need to find out? You need to find out the charge on the plate 2. Where is the plate number 2? Yes, here it is, plate number 2, plate number 2. Yes, both the time it has been connected with the positive polarity. So here the charge that arrive is the Q2 plus Q3. So Q2 plus Q3 should be is equals to 2 epsilon naught A by T multiplied by V. I hope these things are clear. Is it clear? Is it clear? Yes. So can it be done? Can it be done? Are you sure? Okay, so shall I add something to this? May I? Let's have a look. That in the previous question, find out charge on the plate 1, plate 3, plate 4, plate 5. Yes, you need to perform the same task. You need to perform the same task, that which are the charges that arrived on plate 1, which are the charges that arrived on plate 2, which are the charges that arrived on 3. But one more thing, that this is your battery. This is positive terminal, this is negative terminal. So if you are going to calculate the charge on 5th plate, or charge on 1st plate, or charge on 3rd plate, it would be a negative, because it has been connected with the negative polarity of a battery. Please keep this in mind and do it. I'm sure that you will able to do this. Yes. So shall we move to the next question? Shall we? Let's move then. A very good question. Yes. Very, very effective. Let's have a look. What this is. What they ask is the effective capacitance between A and B. How can you do this? First, this is a question which simply looks like a complicated one, but this is not the one. Yes, this is not at all complicated. This can be done very easily. If you see it analytically, then I hope you can observe that. This 3 microfarad, this 3 microfarad, and this 3 microfarad, this three of the capacitors are in parallel. And if they are in parallel, it's a 3, 3, 3, it's a 1, because it's a C by N kind of thing. Yes, so this 3 capacitors can be replaced by a single capacitor of 1 microfarad. Same is the case with here as well, it's a 1 microfarad. Same is the case here as well, it's a 1 microfarad. Same is the case of here as well, it's a 1 microfarad. I hope those things are clear. Now this 1 microfarad and this 1 microfarad are in parallel, and when they are in parallel, it's a kind of C1 plus C2. So if I do it, it's a 2 microfarad. Yes, this has been done. Next, it is this 2 microfarad. Next, it's a 2 microfarad. Next, moving on the next, it's again 2 microfarad. Now it's this 2 microfarad, and this is 1 plus 1. Again, it's a 2 microfarad. It's a 2 microfarad. This is even 2 microfarad. This is point A, and this is point B. Yes, this all are in series, and when they are in series, the C equivalent all having the same value. It's a 2 divided by 6, which will give me a 1/3 of microfarad. This is C equivalent. I hope those things are clear. Is it clear? So can you do this? Can it be done? Are you sure? Very easy questions, very, very easy questions. The only thing that we should have a faith in ourselves, that I have studied enough so that I can do any questions, and stick to the basics. Always stick to the basics. Do not find the shortcuts, and stick to the basics. This will make a question for us, for surely I can do a question. Yes, stick to the basics. So let's have a next question. You are doing pretty well. Well done. Keep going, and let's find out the next question. What they says, what the data is telling me, that in the figure shown, the effective capacity across P and Q is. So what you need to consider is that you need to find out the capacitance. You need to find out the capacitance across P and Q. So what happens? Look at this. If you need to make that which of this capacitors, all this can be considered as a different capacitors. And if they can be considered as a different capacitors, so what I can do is, let's say this is P. This is my first capacitor. it's a C1. This is my second capacitor, this is my third capacitor, and as charge enters here, it needs to move through this too. It is not having any option, and when my charge is not having any option, that means these two are connected in series. So what I need to write is, it's a C2, it's a C3, and these two are connected with this, it's a Q, something like this. I hope this is clear. Yes, is it? Now you need to simply write this C1, C2 and C3. That equivalent of this 2 would be a C2 plus C3, and that has been connected with the C1 in parallel. So let's have a look. My C1, it's a K1 epsilon naught A by 2 into D. My C2, it's a K2 epsilon naught A into D. C3, it's a K3 into epsilon naught A by D. And my C equivalent, I know that C2 and C3 are in, here I made a mistake, sorry. The C2 and C3 are in series, so their equivalent would be C2 C3 divided by C2 plus C3. Yes, so this is C2 C3 divided by C2 plus C3 plus C1. Yes, and replace the value of this. Replace the value and things will be done. I hope this is clear. Is it? So can it be done? Are you sure? Can it be? Can it be done by you guys? Are you sure? Great. Let's move to the next question. Yes, it's an infinite ladder. What they say is the equivalent capacities of the infinite network shown in the figure. You need to find out across AB. Capacity of each capacitor is 1 microfarad. So what do you need to do? Suppose, let's write it down at this point of time. It's a C, and then we are going to replace the value. So what we are supposed to do is, we just observe that from where my network is keep repeating itself. So if I observe this very carefully, what I can have in conclusion is that this block is being repeated, this C, 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 and onwards. So what I need to do is, I need to break the network from here, and I just notice that my answer would be the X, and it is equivalent to this. It's a C, C, even this would be the same. It's an X. Is it clear? Is it clear? I hope this can be done. Yes. Can it be done? Yes. Shall I do a little more? Shall I? Let's have a look. That this was the situation. This is the X equivalent. This was C. Even this was the C. This was the C, and this would be the X, as these two are in parallel. So this can be written as, it's a C, comma, it's C plus X. Now it's a C again, and this is X. So as these three are in the series, what I can have is 1 by X is equals to 1 by C plus 1 by C plus X plus 1 by C, and now rest of the things can be done. Yes, take an LCM and solve this. Yes, then solve and replace the value. Place the value of C as 1 microfarad. Yes, here I already mentioned the answer for your reference purpose, so that you will come to know that my answer is correct or incorrect. Yes, so please do it. And let's move to the next question. Yes, very good question. Yes, you need to remember all these formulas. Yes, that a single question carries each of the formula. Very good question, very good. The question is n identical charged drops. It's a coalesce to form a bigger drop. Yes, so they are going to merge with each other and they are going to make one bigger drop. The new potential, new charge, new capacity, new energy stored, everything that I require. So what I can do is, suppose the things would be something like this. There are the n number of drops are there, something like this, and this are going to combine and it will form a new charge, a new bigger drop. So what's supposed to be done is that each identical charge drops, let's say this is having a charge q, charge q, charge q, charge q, and something like this. So the final charge would be equals to n into q. That means a new charge, sorry, the new charge would be equals to n into q. Yes, that you know. Now what else I know is that volume of the initial system should be equals to volume of the final system. So it's a 4 by 3 multiplied by pi r cube multiplied by n number of drops. That would be equals to 4 by 3 multiplied by pi into r cube. Yes, this 4 by 3 has been gone, this pi has been gone, and my new radius would be equals to n to the power 1/3 multiplied by r. I hope this is clear. Is it clear? So now let's move to the find out the potential. The initial potential of each drop, it's a kq by r. The final potential is equals to k multiplied by n of q divided by radius r. So let's replace this capital R with the small r. It's an n to the power 1/3 into r, n to the power 1/3 into r. So what I can write is it's a k into n into q divided by r should be is equals to n to the power 1/3 into of r. Yes, so let's take a ratio of this. Let's find it out, the ratio of this, and what I can have is it's a vf by vi. That should be is equals to k multiplied by n into q divided by n to the power 1/3 into r multiplied by kq divided by r. This kq would gone, this r are gone, and here it is a n to the power 1. This term, it's an n to the power 1/3. It's a n to the power 1 minus of 1/3. So this is equals to n to the power 2/3. This is vf and this is v initial. This vf is equals to n to the power 2/3 multiplied by v of initial. So I can have a charge, I can have a capacity. This is very important formula. You must remember this. This is very important. Please remember this. Yes. Now let's find out the capacity. C dash, it's a q by v dash. Yes, q is equals to cv, thus c dash is equals to q dash by v dash. My new charge was n into q. My new voltage, it's a potential difference, it's a n to the power 2/3 into v initial. So what I can write is it's a n to the power 1 minus of 2 by 3 multiplied by c initial. So this is equals to 3 minus 2. It's a n to the power 1/3 into c initial. This is c final. I hope this is clear. Yes, this final capacitance would be equals to n to the power 1/3 into c initial. Is it clear? Now what remains? Yes, it's a energy stored that has been left. So how can I do this? Energy stored. What I can do for the energy is energy stored. What I can do, it's an half cv square. So new energy is equals to half into C dash into V square. It's V dash. Yes. So this is equals to half multiplied by my new capacitance. It's a n to the power 1/3 into Ci. So new capacitance, it's a n to the power 1/3 into C initial multiplied by V square. My new potential. New potential, it is equals to n to the power 2/3 into Vi. So this is n to the power 2/3 into Vi whole square. So the term will be, it's in half into n to the power 1/3 into Ci multiplied by n to the power 2/3 whole square. It's n to the power 4/3 Vi square. So if I solve this, it's a half Ci Vi square, which is the initial energy, multiplied by n to the power 1/3 into n to the power 4/3. It's n to the power 1/3 plus 4/3. So what I can write is, it's a U dash, that should be is equals to initial energy Ui multiplied by n to the power 1 plus 5. It's a 5/3. So this U dash by Ui equals to n to the power 5/3. Yes. Yes, this all relations are very important, and you must remember this. These are very important. This as well as this of capacitance, this is very important. Please remember this. Please remember this. This question has been very beautifully crafted. Yes, that a single question has been asked and you need to calculate it for so long. Very beautiful question. Yes, please remember this. Each formula must be remembered. Let's find it out. The next question. Look at this. What they ask? They ask that the equivalent capacitance between point M and N. You need to find out the C equivalent between point M and N. Yes, this point has been grounded. This point has been grounded as well. So what do you need to find out? You need to find out the equivalent capacitance. How can you do this? How can it be done? Yes. So what you need to do is that I know that C is equals to Q divided by delta V. It's a potential difference. So let's write it down. It's a Q divided by potential at M minus of potential at N. Now if you look at this very carefully, it has been grounded. Grounded, that means zero voltage. Even this is grounded, that means it is even zero voltage. So this is Q divided by 0, which will be an infinite. That's it. The task has been done. Did you get the same answer? Do you? Great. So do you enjoy this session? Yes. Let's move to the last question of this session. This is last question. Let's have a look. Do it quickly. Next, 3 uncharged capacitors of capacity C1, C2 and C3 are connected as shown in the figure to one another, and the point A, B and C, that potentials have been given. It's a V1, it's a V2, it's a V3. Then the potential at O. Okay, how should I do it? How should I do it? So what I can write is that let's suppose that a certain charge will be going from V1 to this, let's say charge Q1, and this charge Q1 would be divided in this two charges. It's a Q2 and Q3, and let's say that here it is a potential at O. So what I can write is that this Q1 should be equals to Q2 plus Q3. Shall I redraw the structure? Shall I? Let's have a look. It is something like this. This is V1, this is VO, this is C1. Here the charge has been passed, that is of Q1. Here it is a Q2. This was V2, this was V3, and this is Q3. And this capacitance is C3, this is C2, something like this. Now what I know is, I know that Q is equals to CV. Ideally it is a C into delta V. Let us assume that V1 is at higher potential. Let us assume that V1 is at higher potential. So what I can write is it's a C1 multiplied by V1 minus of V0, that is equals to C2 into bracket VO minus of V2 plus C3 into bracket V0 minus of V3. So the things will be C1 V1 minus of C1 into V0. This is equals to C2 V0 minus of C2 V2 plus C3 into V0 minus of C3 into V3. I hope this is clear. So what I can write is it's a C1 V1. This minus C2 V2 has been shifted to this side. It's a plus C2 V2. This minus C3 V3 has been shifted to this side. It's a plus C3 V3. And that would be equals to all the V0 terms will be arranged on the one of the side. It's a C1 plus C2 plus C3 multiplied by V0. So V0 should be is equals to, it's a C1 V1 plus C2 V2 plus C3 V3 divide by this C1 plus C2 plus C3. That's it. What was your answer? Is it same? Is it? Great work. So let's wind up this class at here as well. Yes, these are the question which have been asked in the previous examinations that have been taken for the engineering admissions. Yes, in the next session we are going to cover the questions that have been asked in the previous year questions that has been asked in the medical competitive examinations. Yes, but I request that before you go for that lecture, please revise this complete syllabus, that is from, let's begin from the what is charge, what is potential and that all stuff. Yes, and start that lecture. Yes, so keep doing, keep trying, keep revising the things. This will make our foundations very, very strong, and that is what we require. Yes, thank you, have a good day, take care.